All right, this is part 2 of chapter 6. Let's take a look at operations strategy and planning. Although many companies have made significant gains during the evolution from mass production to lean production processes, perfection obviously has not been achieved. So you can see kind of the transition from mass production through lean manufacturing to flexible manufacturing to adaptive manufacturing and to today's smart manufacturing. There are 3 time frames covered in the planning horizon: long range, intermediate range, and short range. And long range plans are those covering a year or more, which focus on major decisions regarding capacity and aggregate production plans. Medium range plans span 6 to 18 months and involve tactical decisions regarding employment levels and similar issues. Short range plans range from a few days to a few weeks and deal with specific issues and the details of production, quantities of items to be produced, schedules, and sequences. Resource Requirement Planning, or RRP, is a long-run macro-level planning tool. It helps the operations leaders determine whether aggregate resources are capable of satisfying the aggregate production plan. The next step is to create a rough-cut capacity plan, or RCCP, to check the feasibility of the master production schedule. Capacity requirements planning is used to check the feasibility of the material requirements plan. This short-range capacity planning technique determines in detail the amount of labor and equipment resources required to accomplish production requirements. The Aggregate Production Plan, or APP, is a long-range material plan that translates annual business plans, marketing plans, and forecasts into a production plan for all products produced by a facility. The Master Production Schedule, or MPS, is a medium-range plan that is more detailed than the APP. The MPS breaks down the APP, listing the exact end items to be produced within a specific period. The Materials Requirements Plan, or MRP, is a short-range materials plan that converts information regarding end items in the MPS into a set of time-phase component and part requirements. In terms of production execution decisions, the production strategy and planning outcomes, along with product characteristics, influence the execution methods used for day-to-day operations. Organizations must also establish facility layouts and production flows that are well matched to the demand volume and product variation. Let's think about assembly processes. Specifically, in terms of products that are built either according to plan or demand, their production occurs via one of 4 manufacturing methods: either make-to-stock (MTS), assemble-to-order (ATO), build-to-order (BTO), or engineer-to-order (ETO. MTS is the traditional production method where end item products are usually finished before receipt of a customer order. ATO production commences after receipt of a customer's order. The finished ATO product is generally a combination of standard components and options or accessories specified by the customer. The BTO, also called make-to-order production approach, delays assembly until a confirmed order is received for the product. The end item finished product is generally a combination of standard and custom design components that meet the unique needs of a specific customer. It differs from ATO in the higher level of customization and lower volume level of production. The main advantage of the BTO approach is its ability to handle variety and supply customers with the exact product specification required. ETO production focuses on the creation of highly tailored products for customers whose specifications require unique engineering design or significant customization. In this manufacturing environment, no 2 products are identical, and each order requires detailed cost estimates and tailored pricing. Also known as project manufacturing, successful ETO initiatives depend on effective collaboration between all supply chain participants. Given the widespread proliferation of products, a number of manufacturers take a hybrid approach, where some items are built to stock and others are built to order. Delayed differentiation is one hybrid strategy in which a common product platform is built to stock. One of the key drivers of how production activities will be carried out is facility layout. Facility layout involves the arrangement of machines, storage areas, and other resources within the four walls of a manufacturing or assembly facility. An appropriate successful layout is one that does the following: reduces bottlenecks in moving people or materials, minimizes material handling costs, reduces hazards to personnel, utilizes labor efficiently, increases morale and ease of supervision, utilizes available space effectively and efficiently, provides flexibility, facilitates coordination and face-to-face communication. Production process layouts generally fit into a spectrum that moves from projects to continuous processes. Projects consist of a series of discrete steps that lead to a unique product, like building a bridge. A project layout is a fixed location layout where the product remains in place for the duration of production. A work center is a process-focused layout that groups together similar equipment or functions. The materials move from department to department for completion of similar activities and tasks. This layout provides flexibility in that equipment and personnel can be used where they are needed. Lower equipment investment is needed, and supervisors gain expertise in their functions. The downside of the work center layout are related to the materials handling and movement costs, worker idle time between tasks, and the cost of training and developing a highly skilled workforce that can move between areas. The manufacturing cell is another process-focused layout that dedicates production areas to a narrow range of products that are similar in processing requirements. Setting up a manufacturing cell involves 4 activities: identifying families of parts with similar flow paths, grouping machines into cells based on part families, arranging cells so material movement is minimized, and last, locating large shared machines at the point of use. An assembly line is a product-focused layout in which machines and workers are arranged according to the progressive sequence of operations needed to make a product. An assembly line can begin as many different lines, each devoted to a different component of a product, with the lines converging upon one another, becoming fewer until only one line is left for the final product. Continuous process facilities are similar to assembly lines, with product flowing through a predetermined sequence of stops. The main difference is the continuous rather than discrete nature of the flow. Let's think about packaging. As a product comes off the assembly line, the handoff from production operations to logistics begins. Packaging plays important roles in the smooth transfer of finished goods, and design issues can affect labor and facility efficiency. Well-designed packaging facilitates efficient handling and shipping of the product, keeping landed costs in check. Package design impacts an organization's ability to use space and equipment. A major packaging concern is the ease of handling in relation to materials handling and transportation. Handling ease is quite important to the production manager, whose labor must be used to place the goods in the package. Another primary concern is protecting the goods in the package. Packaging plays a key role in providing information about the package contents. Consumer advocates and government regulators are pushing manufacturers to alter their packaging practices. Barcodes, RFID tags, and other auto ID tools can be attached to or built into the packaging to make product information more readily accessible. When selecting packaging materials, companies today must consider environmental protection as well as product protection and transportation efficiency. Sustainability in packaging is being driven by increased awareness about environmental hazards related to disposal and recycling of packaging wastes, government initiatives to minimize greenhouse gases, and stringent regulations. According to the Sustainable Packaging Coalition, sustainable packaging meets several criteria. It's beneficial, safe, and healthy for individuals and communities throughout its life cycle. It meets criteria for performance and cost. It is sourced, manufactured, transported, and recycled using renewable energy. It optimizes the use of renewable or recycled source materials. It is manufactured using clean production technologies and best practices. It's made from materials healthy in all probable end-of-life scenarios. It's physically designed to optimize materials and energy. And last, it is effectively recovered and utilized in biological and/or industrial closed-loop cycles. So I'd like to end by thinking about production metrics. At the risk of stating the obvious, measurements and key performance indicators, or KPIs, must support operational strategies, organizational objectives, or customer requirements. The following mistakes should be avoided when establishing production metrics for the organization. Using KPIs that are too narrow. This means you should limit the use of metrics that focus on discrete events and isolated points as indicators of overall success of the process. Encouraging wrong outcomes. By this, I mean you need to eliminate measurements that promote activity rather than needed output. Focusing on issues that are not key priorities. In other words, it's important to avoid the development of internally focused myopic production goals that are disconnected from the overall strategy of the organization. Let's look at the golden metrics. Total cost. The most meaningful measurement of total cost is on a cash basis. All money spent on manufacturing must be summarized in the total compared to the previous period, rather than a flexible budget or plan. Total cycle time. Total cycle time is a measure of manufacturing performance that is calculated by studying major purchased components and determining the total days on hand of each one. Delivery performance. Delivery performance is the percentage of customer orders shipped when the customer requested them to be shipped. Quality. The definition of quality will vary by company, but it must focus on quality from the perspective of the customer. And last, of course, is safety. The standard metrics of accident, incident frequency, severity, and cost are important to monitor with continuous improvement, i.e. reduction, as the goal.